In question 11, a block of weight 100 Newton is lying on a rough horizontal surface. If the coefficient of friction between the block and the surface is 1 by root 3, the least possible force that can move the block is. The student, we can solve this question using the straight formula that the minimum force required in these cases is equal to mu mg divided by under root 1 plus mu squares, where symbols have the usual meanings. So this will be 1 by root 3 into 100 divided by 1 plus 1 by 3. This will be, dear student, equal to 50 Newton. And hence option 4 is the correct answer. Now let us solve the question 12. In question 12, there are two blocks given. A block B of mass 5 kg is placed on slab A of mass 20 kg, which lies on a frictionless surface as shown. The coefficient of static friction between the block and the slab is 0.4 and the kinetic friction is 0.2. If a force of F equal to 25 Newton acts on B, then the acceleration of the slab A will be. So we have to find out the acceleration of slab A. Now, dear student, let us draw the free body diagram of B. There will be a rightward force F which is given to be equal to 25 Newton. There will be a backward frictional force small f. The maximum value of frictional force will be equal to mu n, that is 0.4 into normal force, which will be equal to the weight of the body, that is equal to 5 into 10. So this will be equal to 20 Newton. The student, the minimum acceleration for the maximum value of frictional force can be calculated by writing that F minus small f is equal to ma, that is 25 minus 20 is equal to 5 AB, giving AB to be equal to 1 meter per second square. Now, the student, for the free body diagram of A, there will be a rightward frictional force, and this frictional force has a maximum value 20 Newton as you just calculated. So the acceleration for block A will be 20 is equal to mass of A, that is 20 into acceleration of A, meaning that acceleration of A is 1 meter per second square. Since we can see that masses are such that the accelerations of both blocks are coming equal, so they'll move together with an acceleration of 1 meter per second square, making option number 3 as the correct answer. Now let us proceed to the question number 13. In question 13, a particle moves on a horizontal circle with a constant speed. If A is its acceleration and E its kinetic energy, then we have to find out A is constant, E is variable, or none of these. Now, dear student, it is given that the speed is constant. Now, dear students, as the particle moves in a circle, at every point its acceleration is directed toward the center. We can clearly see that the acceleration, even if constant in magnitude, changes in direction. Kinetic energy, which is equal to half mv square, however, remains constant. And hence for this question, the correct answer is option 2. Moving on to question 14. Question 14 says, a simple pendulum of length L carries a bob of mass m. If the breaking strength of the string is 2 mg, then the maximum angular impulse of pendulum from the vertical is. Now, dear student, let us draw the diagram to understand this question. This is a case of vertical circular motion. Now, dear student, please know that the tension is maximum at the lowermost position. If this angle is theta, this vertical displacement will be L 1 minus cos theta. Now, at the lowermost position, T minus mg will be equal to m v square by L, and putting T to be equal to 2 mg, this will be equal to mg is equal to mv square by L. Now, dear student, let us apply the work energy theorem from point A to B. We can write down that the change in the kinetic energy, that is minus half mv square, is equal to work done by gravity, that is minus mgl 1 minus cos theta. Now, dear student, this will give us cos theta to be equal to half or theta to be equal to 60 degree. Therefore, for this question, the correct answer is option 3. Now, moving on to the question 15. Question 15 says a ball of mass small m is rotated in a vertical circle. The difference in the tension at the top and the bottom of the circle will be. Now, the student, this is the topmost position and this is the lowermost position. Let the velocity here be u and here it be v. Let the tension here be T2 and the tension here be T1. Now, at the lowermost position, we can write down that T1 minus mg is equal to m u square by L, and at the topmost position T2 plus mg will be equal to m v square by L. Subtracting these two equations, what we get is that T1 minus T2, dear student, this will be equal to mu square by L minus mv square by L plus 2 mg. Now, dear student, from the work energy theorem, the change in kinetic energy, that is half mv square minus half mu square, will be equal to minus mg into 2L. Now, from this equation, we can write down that v square minus u square is equal to minus 4gl, and we can substitute this in this equation and get that T1 minus T2 is equal to 6 mg. And hence for this question, the correct answer is option 1. Now let us solve the question 16.